Hi guys, so we're going to be looking at lesson 9.3 today. Um, and we're going to talk about, we're going to continue talking about similarity, but things are going to be a little different because now we're going to dilate lines instead of figures. So again, I wanted to just make sure that you guys knew that the extra help sessions will be in D114 and in D136 today. So go see Miss Gracia or Miss Divine if you have any questions, okay? And the videos are up online and the keys, so make sure that you're keeping up with the work, okay? So here's what we're going to do today. Today we're going to talk about how it is that we dilate lines. So whereas before we were dilating figures, today we're going to dilate lines. And how does the dilation impact a line that is on or off the center of dilation? So again, the center is really important. It's going to tell us what's going to happen to the line. First, let's kind of prepare a little bit here. Let's use the word bank to see if we can figure out what's preserved. So when I dilate a figure, a couple of things are preserved. One of those things is parallelism. Okay. And something called that we call orientation. Orientation is the order of the letters when we name a shape. And we're going to talk a little bit about more of that when I come back, okay? And what's not preserved, well, the shapes will always get bigger or smaller depending on the scale factor. So the distance is not preserved. Not preserved means that it changes. And because the distance changes, then their perimeter will change. Okay, so now this is when we talked about dilating a figure. Today we're going to do is we're going to talk about a line. So I wonder what happens when you dilate a line. I wonder what changes. I wonder if anything stays the same. So those are all the things that we're going to talk about today. Okay? All right, so now what I want to do is I want to look at two cases. So I want everybody to take a look at this. This is the first case. Okay, so a couple things before we discussed. Oops, we discussed what we're going to do here. Okay, let me make this bigger so we can see it. All right, so when I look at this line here, so when I look at this line, is the line, is the center of dilation, which is 0, 0, on the line. So if the center of dilation is 0, 0, is 0, 0 on the line? So the answer for number one would be yes, right? So for case number one, the center of dilation is on the line. So for this case, the center of dilation, which is going to be C, is 0, 0, right? The center is 0, 0. Is it on the line? Yes. Okay, so now let's look and see what happens to the actual line. So after I dilate, so it's centered at the origin and the scale factor is 4. Here's what happened to the line. So let me show you. Move this out of the way. Okay. So what happened to the line? So did the line change? Do you guys see any change in the line here? No, the line did not change. Okay, so this is my center. I was dilated, but the line did not change. So we're going to go back here and we're going to say no. Right? The line did not change. Okay, let's take a look at the second case. So again, here the center is 0, 0. Here's my center. There's a line. It's in the scale factor of 4. So now this, again, the center of dilation, which is 0, 0, is not on the line, or the line does not go through the center of orientation, sorry, the center of dilation. So let's take a look and see. So we're going to go back here and we're going to say no. The center of dilation is not on the line. So now let's see what happens to the line. So let me move this out of the way so you guys can see what happened here. All right, so if you noticed some things have changed, right? So what changed about the line? So if you notice, the lines are parallel, which kind of makes sense because in dilations the segments will always be parallel, right? Parallelism is preserved. But what did change? What changed? So the slopes are going to be the same, but what changed is the y-intercept. Okay, more specifically, do you guys remember what the scale factor was? It was 4, right? So we went from 2 to 8. So the scale factor is actually affecting the y-intercept of the line. Okay, so did the line change? Yes. So how did it change? The y-intercept was multiplied by the scale factor. All right? So that's how the line changed. So where the center is, and if the line goes through the center or not, is going to be something that's going to affect how my line looks. So the center, which was the origin, is not on the line here, but here it is on the line. Okay? All right, so here's the key point here. If a dilation maps a line that doesn't go through the center of dilation, then the image is going to be parallel to the pre-image. They're always going to be parallel no matter what. And the y-intercept is going to change by multiplying it by the scale factor, which is k, okay, when centered at the origin here. So what happens if I dilate a line and the line does uh, it does pass through the center of dilation? So then the image and the pre-image are going to be the same line. So nothing will change. So if the center of dilation is on the line, and nothing will change. The image is going to be right on top of the image. The lines will be the same. Okay? Okay, so now let's go ahead and try it. Now, how do I actually figure out where the line is going to be? So it's going to look very familiar because it's going to be, the procedure is going to be um, very similar to what we've done the last couple of days with um, dilation of figures. So here's the question. This is a graph line y equals 2x plus 4 and its image after a dilation with a scale factor of 1 over 3 and a center of dilation at 3 negative or at positive 3 positive 1. Here's the notation. Okay, so the center is going to be 3 1 and the scale factor is going to be 1 over 3. Okay, so it's going to look very familiar because it's pretty much the same procedure. Okay, so now what I want to look at is I want to first plot the center. The center is 3 1, which is going to be right here. Here's my center here. Okay, so now what we want to do is we want to really just focus on where a point is going to be on the pre-image and the image. So if I graph my line, the first thing I want to do is I want to graph my line. So I want to take a look at the pre-image. So the pre-image is going to be at y equals 2x plus 4. So 4 is the y-intercept. And then the slope is going to be 2. Okay, so I'm going up 2 to the right 2, up 2 to the right 2. If I want to go backwards, I'm going down 2 to the left 1. Sorry, up 2 to the right 1, up 2 to the right 1. And if I'm going backwards, I'm going to go down 2 to the left 1. So that's how I'm going to graph my line here. Down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. So here's my line. Okay, let me just connect it here. Let me make this. So here is going to be, oops, let's try this again. Okay, so I'm going to start. Okay, so here's my line. This is the original line, so this is my pre-image. Okay, so I want to graph my image. So it's very similar. You know that the pre-image and the image are always going to be parallel. So the new line is going to have the same slope as this. So I know the new line is going to have a slope of 2. I just don't know where the y-intercept is going to be. So in order to figure out what the y-intercept is going to be, I'm going to go back just like what we did with the shape with the polygons. We're going to look at the center of dilation, and we're going to look at the rise and the run from the center to the y-intercept. Because I know that point is on the pre-image, and I want to find the new point. So if I look at C, I'm going to first count, just like what we did before, we're going to count the rise, we're going to count the run, and then we're going to multiply by the scale factor. So if I start at C, what's from C to the y-intercept here? It's up 4. So 1, 2, 3, 4. And then, so it's positive 4 is the rise. Guys, sorry. I graphed C wrong here. C is 3, 1. So go back to C here. There we go. Fix that for me. Sorry about that. Okay, so we're going to count. So rise and run. So 1, 2, 3 up. So it's positive 3. I'm going to go here. And then we're going to go, let's see, 1, 2, 3, up 3, and then 1, 2, 3 left. So it's going to be negative 3. Okay, now the scale factor was 1/3, so we're going to multiply each of those by 1/3. Okay, so when I multiply, I get 1, and I get negative 1. So again, just like what we did the last couple of days, from C, we're going to count this new distance, and that's going to tell us what the new y-intercept is going to be of the new line. So we're going to go, the rise is 1, so up 1, and the run is negative 1 to the left 1. Up 1 to the left 1. So, well, it's not going to be the new y-intercept, sorry. It's just going to be a new point on the line. So up 1 to the left 1. So I know that the line has to go through that point, right? That has to be a new point on the line. It's not the new y-intercept, but we can figure that out by graphing or algebraically. But it is going to be a new point on the line. So the point went from here to here, right? So it's going to be a point on the line. Now, don't we know the same slope? Don't we know that they're going to have the same slope? Yes, because when I dilate, parallelism is preserved. So what was the slope of the original line? It was 2, or 2 over 1, right? So we're going to do the same thing to find the other points on this line. Down 2 to the left, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Oh, sorry. Gosh, sorry guys. I didn't mean to mess you guys up. Remember, we're starting, it's not from C, it's from the new point. Sorry about that. So we're going down 1 to the left 1, down 1 to the left 1, down 1, down 2 to the left 1, down 2 to the left 1. 2, 1, 2, 1, 2, 1. Okay, and then with your ruler, straight edge, we're just going to connect these points here. Let's make it another color. So let's make it maybe a green line. Let's see if we can do that. Here. Well, hold on one sec, guys. Sorry. Try this. A little tricky with a tablet. Okay. See if I can make it another color here. Okay, it's not liking that, so let's just stick to black. Sorry, guys. Let's just make it. There we go. Okay. It's not really picking it. Okay. Best I could. So here's my U line. There's my U line. But in any case, you can see where the new y-intercept is going to be. It's right there. It crosses right there. Okay, so same slope, new y-intercept. How did I get that point on the line? I got it by doing the same scaling method that we did yesterday with the polygons. Okay, so we're going to graph the new line. Now, one of the things that we can do, so how do we do this? There's two methods, right? There's two methods. The first method is by actually graphing the line, right? So we're going to graph the line. Um, and then we can write the equation, right, of that line. Okay, which is what? If we stop, so that's the method we use here. So what's going to be the new equation of the new line? It's going to be y equals the same slope, 2x, and what's the new y-intercept? -2. So that's the new equation. That's the image. That's the line that's the image of the line that we've dilated. Or what else that's another method. So once you find that point, so what if the y-intercept is not a nice number? If the y-intercept isn't a nice number, then your best bet is to actually just do a little bit of algebra. How do we do that? Well, if I know a point on the line and I know the slope, then I can just plug it into the point slope formula. Right? So you can just use y minus y1 equals slope times x minus x1. Right? Because you're going to know this the same slope as the original one, and then you'll know a point on the line, so you'll have x and y. Okay, so it's whatever method, but you do always have to find the point on the line. And how do you find the point on the line? You find it by doing this. Okay, so you're always going to start at C, count the rise and the run to the old y-intercept, and then multiply with the scale factor, so it's going to give you a point on the new line. And then once you count with the slope, you can get the y-intercept that way. Okay? So let's take a look and see at the next question here. Let's take a look and see this question here. Okay, so question says, if the equation of line H is 3x plus y, line M is the image of line H after a dilation of scale factor 4 with respect to the origin. So that means it's center of the origin. What's the equation of the new line? Okay, so I know that this is line H. Let's make it look a little nicer. So it's 3x plus y equals 2. So we're going to subtract 3x on both sides. Y equals negative 3x plus 2. Okay, so let's graph line H. So we know that y-intercept is 2. And we know the slope is -3. So we're going to go down 3 to the right 1. 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 Up 3 to the left 1. Up 3 to the left 1. Okay, so then there's my line. Let's try this again. Hopefully it works this time. Let's see if we can. Ooh. Oh, I know what I was doing wrong. Sorry, guys. It's a little tricky with the tablet, but I'll do my best. There you go. Okay, so this is the original line. So this is my y equals -3x plus 2. Okay, so now what I want to do is I want to know what the equation of line M is. Line M is the image of H after a scale factor of 4 and is respect to the origin, right? So the center of dilation is the origin. There's my center there. Okay, so now what I want to do is I want to do the counting method, which we've been doing to find and then a point on the new line. So if I look at the rise, let's see the rise here, from the center to the y-intercept, because we need a point on the line, right? So the rise is 1, 2, times the scale factor, which is 4. So the new rise is going to be 8 from the center. The new run is going to be what? The new run is going to be, well, the run here is 0 because we're not going up or down. So when we multiply by 4, it's going to be 0. So we're not going anywhere. Okay, so let's take a look. So so to find a new point on the new line, we're going to go up 8, run 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the point on the new line. Now because it's a dilation, they remain parallel. If I want to actually draw the line, I just have to use the same slope as this one, which was -3. So we're going to go down 3 to the right 1, 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 so on and so forth. Okay, and then I can connect it with my line here. Let's see if I can do another color here. There's my new line. So when you're centered at the origin, if you guys notice the equation of the pre-image and the image, when the center of dilation is the origin, it's actually a little bit easier to figure out what the new line is going to be, because let's write the equation of the new line. If I write the equation of the new line here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this line will be y equals -3x plus 8. Okay, so now if it's centered at the origin, something really cool happens. It's actually a nice little shortcut. Since we know the slopes are going to be the same, then how are the y-intercepts changing? We went from 2 to 4 to 8. So what we're doing is we're just multiplying the y-intercept by the scale factor. Okay, so what do you notice about the equation? And this is important, this only happens when it's centered at the origin. So we're going to just multiply the y-intercept by the scale factor. Right? And the slope stays the same because of dilation and parallelism. Parallelism stays the same. Okay, so that's a nice little shortcut if it's centered at the origin. Right? So if the center of dilation is the origin, that's the only thing we need to do. Okay, and we'll talk about one more case. So now if you're thinking about it backwards, so take a look at this question. It says line P is the image of line L. The equation of line P is given as y equals -4/3 x plus 12. If line L was dilated by a scale factor 3 centered at the origin, what's the equation of line L? Okay, so now P is the image of L. So we don't know what L is, but we know what P is. Okay, so we know P is this guy. Y equals -4/3 x plus 12. Okay, so now what do we know? We know the center is the origin, right? First and foremost, because a dilation happened here, it's been dilated, then what do you know about the pre-image and the image? They're going to have the same slope. So I know right away that the slope of the pre-image has to be the same as the slope of the image. And because it's centered at the origin and what we just talked about, I know that whatever y-intercept was here, when it got dilated by a scale factor of 4, it turned into 12. So whatever number y-intercept is in this line, that number times 4 is going to be 12. So I can think of it like that, right? So what number do we multiply? I'm sorry, scale factor of 3. So change that. Change that to 3. Change that to 3. So if I multiply some number here, right, some number here multiplied by 3 will give me 12. Because that's what happens when you dilate a line that's centered at the origin. The only thing that will change is the y-intercept. How does the y-intercept change? It's multiplied by the scale factor. So you have to think of yourself, well, can you think of a number that I can multiply by 3 that will give me 12, or it has to be 4? It's got to be 4. Okay, so what's the equation of line L? Same slope, and then you think of the new y-intercept as, it's got to be a factor of 12, right? It has to be, so whatever number's here was multiplied by 3 to get to 12. And this happens only, remember, this is important because it only happens when the center is 0, 0. Okay? At the origin. That's when it's going to happen. That's the only time it happens. Okay? All right, so go ahead and sit next to someone and practice for the rest of the period. Look at the notes online, look at the practice, look at the keys, and go to extra help if you want to go over any of this with any of your teachers, okay? The geometry